line downtime because the material is not delivered on time. Material searching for hours in the shop floor, error-prone manual material requests. Do you wish a solution for these kind of problems? Let's see that. Welcome to the show.
Welcome to another season, to another episode of Facts on Open Automation. What are your biggest drivers of manufacturing costs? Is it equipment? Definitely not. Is it labor? You would be surprised. Labor does make a relatively small percentage of your production cost. As this survey of Morgan Stanley shows, it's across 16 to 30% across different manufacturing industries in the US. No, it's raw materials and components. Those are your biggest drivers for your production costs. And what else would make sense than to get a clear view on your material situation? And that's exactly what we are going to explore today. And more than that, we are going to explore some hidden challenges in your material workflow, like static material planning or component quality issues. And we will explore some tools. And I'm super glad to have two fantastic colleagues with me to discuss this. Hello, Alex.
Hello, Laszlo.
And hello, Michi.
Hi, Laszlo.
Both of you visit a lot of manufacturing sites. Alex, you especially talk to a lot of people whose job is related to material management. What is one of your insights from those visits?
Well, many of our customers, they are using different systems in the area of material management. Some are using self-developed in-house solutions. Some others are using MES or ERP system. All these systems, there are a lot of advantages. But on the other hand, they are not able to cover the full flow of the material management.
I see. So let's write clear the main question. How do you get a clear view on your material situation?
So basically, I visit a lot of customers, you already mentioned, and during this visit, I figured out there's still a lot of manual work. That means the degree of automation is quite low. And also, I found a survey, and this survey talks about material automation, and it says that 82% of the respondents in that survey said that material handling is quite important. That means there's a lot of room of improvement.
So automation across the full material management.
Exactly. Automation is the key.
There are many supply chain challenges nowadays in the world. I remember cars produced with older chipsets. What are some of the more dangerous ones for you out there?
Currently, the biggest issue is in terms of material management, the long lead times for the components. So here I found a second survey, and this goes also in the same direction. It says that nearly 8 out of 10 of all the manufacturers here in this survey told that the biggest challenge is the lack of material, lack of components.
So, and the issues then in the production, what we have.
Exactly, and therefore it's much more important to have a very good transparency over all the material.
And for you, Michi?
Fake components. We're facing more and more, or our customers facing more and more fake components, which means this is the worst case, you have a non-working component in your production. Second part is you have a mixture of components, because we weren't aware about this, but it's coming more and more since the last 3 years that our suppliers, they are mixing components. So if you have a batch and you cannot fulfill the batch, you just fill it with another supplier.
You just fill it with the material of the competitor.
Yeah, the neighbor one.
So in what form do wrong components occur in electronic manufacturing?
Of course, the first one, which is really the worst case, is the fake one, which happens in the income, in the warehouse, whatever it is. But secondly, which is a daily business, is that we're facing splicing errors. We're facing labeling errors. We're facing setup errors, and this is quite common.
So how can a manufacturer help himself? What solutions does he have to find those components?
Like Alex said, we have the possibility in the income, in the wear income, if you have good trained people, a good system, whatever it is. If we're talking about if you're in production, so if you have the components in line, you have just the solution like our SIPLACE Measuring Feeder X, which I have prepared here. I brought it with me. So this is a perfect solution for a perfect example for automation. So we have a standard feeder. You see it's 8 millimeter, very tiny one. And this feeder can measure components in line. So you can be really sure that you have the right component in the right place in the line. And therefore, I have prepared a short video for all of us. So here we are with the item of interest, our SIPLACE Measuring Feeder X. The feeder is an on-demand device to detect components and the component range. What can we do with the feeder? We can detect splicing issues, we can detect labeling issues or setup issues. And last but not least, of course, we can detect customer deviations if you have, for instance, fake component. What is the range of it? We can measure resistors, conductors, we can measure diodes and inductors. So, and the maximum size of it, of the component itself, can be 6 by 3.2 millimeter, and the minimum size is 0.2 or 1 inch. And all this functionality within an 8 millimeter feeder. So now we are here on the SIPLACE Pro Desk to program or specify the component itself. We have here an open component, an 0201 C chip. In standard-wise, everything is set up. So the important stuff is here on the electrical characteristics. So you can see, at first you have to define the component type, and if we open the drop-down, you see the range, resistors as described, standard, capacitor, polarized capacitor, inductor, diode, and that's it. So we're starting with resistor, and as a resistor you have the value, of course, how much ohm you want, what kinds of measuring range, and of course the tolerance from the component itself. As well, we can go for symmetrical tolerance or not symmetrical tolerance. As well, on the right side you see the direction of the component or orientation itself. Same we do for capacitors. Set up the value, what do you want, the range, the symmetrical tolerances, measuring frequency is here as a default, or you go from 120 Hertz to up to 10 kilohertz, and of course a measuring voltage, which can be set as well. Third of one, number three, is the inductor, and with the inductor as well you have the value itself, the range, the symmetrical tolerance, as well the orientation. Last but not least, diode. You see the lower limit, the nominal value, and the upper limit, and as well if you want to use custom measurement current that you can change here from 2 or 10. So for all the component interest, the most interesting stuff is on the right side where we see the electrical verification. We switch it on, and then you have more different possibilities. At first you can verify in a period, like every 1,000, every 10,000 component will be checked. Second, you can verify in a sequence, like this example here, 10, 100, 1,000 or 10,000. And last but not least, you can discard the gray zone and dispose it in a reject bin if you don't have a splice sensor. So that's it from the SIPLACE Pro part. So what do you get in the end with the SIPLACE Measuring Feeder X? You get no wrong component on the line because we can measure every component within its range. You have no operator issues because we can detect splicing errors, labeling errors, setup errors. You have always the right reel after splicing if you have a splice detector. And all this leads to less rework, and this feeder is available on every SIPLACE machine and on every head.
You're a validation expert, the Measuring Feeder X. Michi, what was the main purpose to develop this feeder?
Of course, you have a quality view, a quality tracker about it. You have an extended traceability, and of course, in the end, you get a clear view about what component is on your board.
Perfect. Clear view is the right word for you, Alex. So we discussed clear view at the beginning, and you mentioned also ERP. So if someone has an enterprise resource planning system, he should have a clear view.
Yes, that's right. But the problem here is that the ERP system or MES system does not have all the information. In most cases, they have no idea about the storage location, no clue about the carbon quantity or about the status of the different materials. Therefore, our suggestion is to have an expert system in the field of material management. This expert system has all the information which is needed to give the ERP system all the data, and therefore the ERP system has a chance to have a better planning.
I see. So the system you suggest, he knows how much material is there in the production, and he knows where it is located.
Exactly. This is the main purpose of a modern material management expert system. This system has an online view to the line. That means online quantity, online inventory, knows all the carbon locations of the material, and also all the time the status of the material.
And this system calculates the total material demand for one day and arranges the total material to be delivered to the line?
No, Laszlo, there's no need to pick all the material for one order or more orders, because by doing so, there's a lot of disadvantages. For example, the material will be bound to a certain line and cannot be used for other lines. Or, on the other hand, you're reserving very, very expensive space in the shop floor. And that's the reason we suggest to make it a little bit different, just to release the material from the warehouse at that point of time when it's needed. For example, you can arrange your warehouse with some modern tools that you release the material every 2 hours based on a time slice.
On time slice, I see. So what solution do we have here to offer?
We have developed a quite new tool which is called the Works Material Demand Calculation. Actually, I prepared a video for the audience where we explain in detail how does it work with the material demand calculation. Our smart shop floor management suite Works is designed to manage your workflows in the shop floor and get the best out of your production lines and make your life easier. What do we mean by Works Material Demand Calculation? Material demand calculation is a time-based material supply. That means that the material demand is based on orders in the near future. Material is requested for the production line by time slices. For example, every 2 hours, material is provided by the production line for the material which is needed for the future for the 2 hours. Works material demand calculation is considering the material consumption at the line and also the progress of the different orders in the shop floor. We do not request material for the whole orders or for several orders. The main idea behind material demand calculation is that the material is only requested when it's really needed. First, we choose all jobs or recipe we like to produce in the near future. This is the base of the whole material planning. A planning horizon can be, for example, 1, 2, or 3 days. The jobs will be imported in the planning tab via drag and drop. Then you may do a rescheduling of the sequence of the jobs if necessary. You may move the order on the timeline by moving it to the right place. The next step is the approval of the jobs. You mark all jobs which will be produced soon, and then you click the Approve button. After doing the approval for the jobs, some data will be generated automatically in the background. The monitoring Gantt chart is updated. You get a graphical representation in a time axis at what time the different tasks and the production should be started. The time required to pick material from storage, the time required for setup preparation, and the time needed for the production. Here, the bars are colored accordingly when there are delays, so that one can follow online the status of the activities in the production. Material requirement lists are now created in the Works Material Manager. The lists contain all material which is needed for the production line within the next time slice, for example, for the next 2 hours. A separate list is created for each table or setup location. By creating the setup task in Works Setup Center, the operator in a setup area gets the information which setup is to be prepared and when the work must be completed. In the last step, entries are created in the line control GUI so that the operator receives information about which job is to be produced next. What are the advantages of Works Material Demand Calculation? It reduces line downtime because the material is always ordered automatically. Components are not bound to a certain production line for a longer period of time. Also, it reduces inventory for the line-side stock. It saves labor cost by just reducing the number of transports between the warehouse and the shop floor. And it increases the transparency by using our Gantt chart for all activities in the warehouse, in the offline area, and at the production lines. And finally, it generates the material requirement lists automatically. The goal is always to have the right material at the right time, at the right place, and in the right amount.
By the way, if you want to have a remote demonstration on material demand calculation, you can do it. Just contact your friendly local ASMPT account manager. Alex, another question to you. I've read that the biggest problem in implementing an automation is first of all in implementing it into an existing system and training. What is the case with material demand calculation here?
Material demand calculation is a part of our Works software suite. And that means that the integration is quite easy. And as we already saw in the video, that the usage of the software is very easy. And there's no need to have an elaborate training at all.
Can you briefly then summarize the benefits of our material management?
The greatest benefits of our material management solution is that you have the perfect transparency of all the material, that you always know where's the material located, you have an online view about the inventory, and you know also the status of any material.
The final question to both of you. What would be the one piece of advice you would give to our audience to think about?
2 pieces, of course, globally wise. I'm quite sure Alex will answer. If you consider if you just focus on the line or in line, it is very important to be sure what component is on your feeder, on your line, to avoid all these splicing issues, all these labeling issues and setup issues.
And for you, Alex, what is your last piece, one piece of advice?
Well, my honest advice is develop and follow your vision. As an example, a couple of years ago, I visited the customer Vega at the Black Forest. And these guys, they developed a very clear vision what they like to do in the future in terms of automation. And right now, they put the whole production on a new level and they save a lot of money.
Follow your vision. Cool final words. Thanks, both of you, for your expertise. I have also some final advices to our audience. If you want to visit ASMPT, if you want to see ASMPT, you can do that in one of the following events, which you see listed down in the ticker. As mentioned, you can get more information as a download link in the description of the show. Please do not forget to hit the subscription button if you want to stay updated on automation in the electronics manufacturing field. Last but not least, we will see each other next month. Thanks for both of you for being here. Thanks for you all for joining us. Have a nice day and stay open.